Hi there guys. So today we're going to continue factoring by using a method called the difference of squares. So as we get started, I want to make sure we understand what that word means. Difference means subtraction, okay? So this method works if we are subtracting squares. That means perfect squares. So what are some of our perfect square numbers? 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4, so 1 is a perfect square. 4 is a perfect square because we have 2 times 2. 9 is a perfect square, 3 times 3. 16, 4 times 4. 25, 5 times 5. X squared is a perfect square. Let's put the 1 times 1 over there because of x times x. You know what? X to the fourth is a perfect square because of x squared times x squared. Okay, x to the sixth is a perfect square because we could do x cubed times x cubed. So there's a lot of perfect squares. So this is a special case. For example, if I had something like x squared minus 16. Okay, so I notice that it is subtraction. This has to be subtraction. Okay, and then I notice that x squared is a perfect square because it's x times x, and 16 is a perfect square, it's 4 times 4. Okay, so what is so fun about this one is that you could go through the process and you could find your two numbers that multiply to negative 16 that would add to the middle term, but that middle term is 0x. So you could totally do this, but there is a little faster way, okay? It's to notice what you do is you take the x squared and you take, like, what times what gives me x squared? That perfect square, it's just x and x. You put those in the front. And then my 16 is 4 times 4, so you put the 4 in the 4. And then for every single difference of squares, what are the symbols that go there? Always a plus and a minus. All right, always, always. It doesn't matter what order you do it in, but that will always be plus or minus. So if we check by distributing, so x plus 4 times x minus 4, so I'm going to distribute these in. So x times x is x squared. X times negative 4 is 4x. 4 times x is 4x. And 4 times negative 4 is negative 16. As long as you have a plus and then a minus, those two middle terms will cancel each other out, and so you're just left with our x squared minus 16. Okay, let's do another one. Let's move down here. Let's do, how about 49 x squared minus 100. Okay, so we have a difference, it is subtraction, and we have a perfect square in 100 because 10 times 10 is 100. We have a perfect square in 49 because 7 times 7 is 49, and a perfect square in x squared. So when I want to factor it, we're going to have our two sets of parentheses, and we're going to take our perfect square number, 7 times 7 is 49, so we're going to put a 7 in the front, and x times x is x squared, so we're going to put an x in each one. And then our 100 is 10 times 10, so we're going to put a 10 and a 10. And then what are our symbols? Plus and minus. And you're done. Okay, sometimes they're going to try to trick you. And they're going to say, well, let's put 36 minus 9. No, let's not do that one. Let's do 36 minus 49 x squared. So they're going to switch the order, but just because the x's are on the right hand side, it doesn't have to change your process. Say what times what equals these, and then put them in the order that you see them in, into the parentheses. So here are my parentheses. In the first term, it's a perfect square, and we are subtracting, and so 6 times 6 is 36. I'm going to put a 6 and a 6. In my second term, 7 times 7, and the x times x, and then plus minus. Okay, so also sometimes they're going to try to say, like, what, can you do this? Can I do 16x squared plus 25? Can I factor that? That is a big fat no. What is this one missing? Yes, we have a perfect square, 4 times 4 and x times x, and yes, we have a perfect square, 5 times 5, but this is called the difference of squares. Do I have a difference right here? Is there a difference right here? No, that is a plus sign, which means you cannot actually factor this one. There is no greatest common factor. There's a plus sign. This one cannot be factored. Okay, and so be very, very, very careful when you see perfect squares. There must be a subtraction sign. Another common mistake students make is if they had something like, let's say I had x squared minus 6, no, not 16. Let's do x squared minus, I'm making up this problem, minus 14. And they're going to say, hey, that works. There's a subtraction sign. They're going to say this is x minus 7 and x plus 7. Oops, what was our mistake here? This 14 is not a perfect square. They were thinking 7 plus 7 equals 14. No, 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 no. It has to be 7 times 7, which does not equal 14. So this one also cannot be factored. Okay, so practice and reach out to me if you need help.